Hi, I'm Jovan, and together with Xuan, I'll present to you Group 15 of the periodic table. So we will cover where is Group 15, what is Group 15, and then how is it different from Group 14 and 16, the importance of Group 15 elements, and the trends in Group 15. I'll start off with an introduction to Group 15 elements. This is commonly known as the periodic table, and this is group 15. It is also called the nitrogen group, with the electronic configuration of ns2np3, with n being the principal quantum number. As you can see, the p shell is half filled here. This will be important when comparing with group 16 elements. All elements will have 5 valence electrons, and it includes both non-metals and metals. Following general periodic table trends, the first ionization energy of group 15 elements will go down a group.
Now I'll be covering comparison of group 15, which is neighboring groups group 14 and group 16. So these are some group 14 properties. These are some group 15 properties. And these are some group 16 properties. And these will be elaborated more on later. Now, group 14 versus group 15. Group 15 has smaller atomic radii than group 14 elements. They also have one more valence electron than group 14 elements. The first ionization energies of group 15 elements are greater than those of group 14 elements in the same period as them. Group 15 elements also have higher electronegativity values than group 14 elements and are less metallic than group 14 elements. Whereas for group 15 versus group 16, group 15 elements have bigger atomic radii than group 16 elements. Group 15 elements have one less valence electron than group 16 elements. The maximum first ionization energy in group 15 is greater than that of the group 16, but the minimum first ionization energy of group 15 is lower than that of group 16. Group 15 elements also have lower electronegativity values than group 16 elements and are more metallic than group 16 elements. Now, some basic importance of the elements in group 15. Nitrogen. So, as you probably know, 78% of the atmosphere is made of nitrogen. This means that every time you breathe, 78% of the air you breathe in is nitrogen. Furthermore, all living organisms require nitrogen because nitrogen plays an important role in the building of proteins and amino acids, which are crucial to carrying out normal bodily functions. The main molecule given out from the Haber process is ammonia. The Haber process is basically nitrogen and hydrogen put together under high pressures to form ammonia. Now, phosphorus is an important element in our DNA and RNA, which is the building blocks of our body. Red phosphorus is also the main ingredient in matches. It's the red tip of the wooden stick in a match. So basically, phosphorus is useful both in maintaining how we look like even in our body, and also basic survival skills, because it helps create fire. Arsenic is very commonly known as a poison, and especially in the early 18th century, arsenic was a commonly used poison in the UK. Basically, why it was so commonly used was because that by the time you detected arsenic in a person's body, the person is already dead and you have gotten away with murder. However, after that, they found a way to detect it quickly, so it became less common. Now, antimony doesn't really have significant importance as of this point, but probably in the future, they'll probably find some way to use antimony to benefit us. Now, you may know bismuth as the shiny, pretty crystals. However, bismuth subsalicylate is also a commonly used antacid in America, which is known as Pepto-Bismol in the form of a pink liquid. Moscovium, and as the name suggests, is found by Russian scientists, and they named it after their capital, Moscow. It is a super heavy element and found relatively recently in 2003.
Moving on, we'll cover some trends in group 15. So, it's pretty obvious that the mass goes down a group due to its increased number of protons and neutrons. The electron configuration has also some difference, with its principal quantum number increasing by 1 as we go down the group. So nitrogen starts with 2s2 2p3 and it moves down to 7s2 7b3 in Moscovium. The p shell is half-filled as previously mentioned, which gives it a slightly higher first ionization energy than group 16 elements, as it's harder to remove one electron from 3 half-filled orbitals than 2 half-filled orbitals and 1 fully filled orbitals. The electronegativity decreases down the group due to the increasing distance from fluorine, and the covalent radius, also known as atomic radius, increases down the group as the principal quantum number increases, which means the shells are further away from the electrons. So in its common physical form, nitrogen is a colorless gas. The two allotropes of phosphorus, white phosphorus and red phosphorus, are its common physical forms. Arsenic can be found as a yellow solid or grey solid, antimony a yellow solid or silver-white metallic solid, and bismuth, which is quite interesting as it's a pink-white metallic solid. The color pink is rarely seen in chemistry. That's all we have for today. Thank you.